Hey, 201ers. We're just going to kind of have story time for this lecture. I do really want you to read chapter 11 because we're going to have two lectures using the whiteboard, and then I'm going to do a screen share where I'm solving a linear programming problem in Excel, and you can see that on my computer. So there's a little bit of a learning curve when it comes to Excel. We're not going to do anything evaluative using Excel, but it is a really nice transition from a simple linear programming problem to a more complex one that you can solve without much Excel knowledge at all. But what we're going to do today is really just look at what whole farm planning is and why that is really kind of synonymous with linear programming. So to begin with, the planning procedure is really about what we've been doing in this class up until now. You know, I'm not going to ask you to memorize the 6 steps, but determining objectives and specifying goals, I mean, that's writing a mission statement. That's understanding why you're in business, what do we do, and why do we do it. Inventorying available resources is about scanning and understanding what you can do. Thirdly, identifying possible enterprises and technical coefficients. And step 4, estimating gross margins, is enterprise budgeting. So when you're identifying technical coefficients, a technical coefficient is how much per unit of output do we use of an input. So now I'm thinking that an example would be better than this definition. So if we're talking about corn, for example, so if our decision unit would be how many acres of corn are we going to plant, a technical coefficient is how much of each resource do we need to plant each acre of corn. So we can go to the enterprise budget. We did this, it's on page 180. So the enterprise budget for corn right here tells us our technical coefficients. So we need 28,000 seeds when we plant. We need 140 pounds of nitrogen. So 140, that's the technical coefficient. The 28,000 is the technical coefficient. And the thing about linear programming that maybe makes things a little bit harder than it needs to be is it has its own lingo and terminology. And if you can get over that, then it helps us solve the fundamental problem that linear programming addresses. And that is how to maximize overall profit when the obvious answer isn't always correct. So let's move back on to our reading. Just pretend like you're one of my kids. They get read to over their Zoom meetings, and we'll read through them as well. But if we look at chapter 11, and we get past this initial part about understanding what our inventory is, our building, our machinery, and our capital. And capital is an important one, and capital will be referred to as financial capital. How much money do we have, or how much credit do we have available? Labor as well. Once we get past that, and please read that, it will reinforce what we're learning here. We then are going to estimate our gross margin per unit of our possible enterprises, and then figure out what combination of those enterprises we are going to use. So if you go to table 11-2, we have potential enterprises and resource requirements, and then below that, we have gross margins. So if we can plant Class A cropland, our resources are 2 varying qualities of cropland, some pasture, some labor, and some operating capital. And we have all of these choices of things that we can produce given those resources. We can produce cotton, soybeans, and corn. Again, so we get kind of sophisticated and complicated right away. What do you mean we can produce corn twice? Well, you can produce corn either on the A cropland or on the B cropland. I wish that this example, it's a great example. The one thing that I would change is I might say we have irrigated cropland and we have dryland crop. So we can plant corn where it's irrigated or corn where it's non-irrigated, but we're still planting corn. Down below, our gross margin is the same thing as profit contribution, or how much profit above variable cost do we have? Because what we're doing is we're looking at these different enterprises and we're saying, okay, each acre of corn is going to add to profit this much. Each acre of soybeans is going to add this much. Each animal that we raise is going to add this much to profit. And in the end, we want to maximize all of the profit put together. So we're going to skip that and go all the way to the appendix, the graphical example of linear programming. We're going to talk about a simple example, and then that should set you up well to read. And we're going to talk about how the obvious answer isn't necessarily so. So if we look at table 11.8, we have information for our linear programming example. And it's saying that we have 120 acres of ground, 500 hours of labor, $30,000 of operating capital, and our gross margin is $120 for every acre of corn and $96 for every acre of soybeans. So this is saying that we're going to make 25% more profit for every acre of corn that we plant than soybeans. So I know a lot of you have good agronomic knowledge, you're good plant scientists, you understand that a rotation, there could be a premise for this. Let's say there's not. Let's say that this is just crop A and crop B. Crop A has a gross margin of $120 per acre. Crop B has a gross margin of $96. Why in the world would we ever produce soybeans, crop B, that has a profit contribution of only $96 when crop A has a profit contribution of $120? It's because of the technical coefficients that go into producing that. For instance, it takes $200 of operating capital to plant an acre of corn. Now you might say, well, so your profit really isn't that much. No. The gross margin is really the profit. We might have $600 of revenue from an acre of corn and $480 of cost, or we have $320 of revenue from corn and $200 of cost, my operating capital, because that's really what that's saying. How much money do you need to plant? How much money do you need for inputs? Whereas soybeans, my gross margin of $96 really means that my overall revenue is $256, less the $160 that it takes to plant. So what does that have to do with why you would ever plant soybeans? Well, think about this. I've got $30,000 of operating capital. If I plant all corn, I can plant all 120 acres because 120 times 200 is $24,000. However, if I only had $20,000 of operating capital, then I wouldn't be able to plant as much corn. I would be left with bare ground. Similarly, with my labor, I have 500 hours of labor, and it takes 5 hours to plant an acre of corn, which means that if I only plant corn, I'm going to run out of labor, and I will only plant 100 acres. I'll have 20 acres that are left over. So instead of the trade-off in revenue being $120 to $96, because we're thinking about a one-to-one trade-off, it only takes 3 hours to plant an acre of soybeans. So if I use 5 hours to plant 1 acre of corn, that adds $120 of profit contribution. If I use 5 hours of labor to plant soybeans, I can plant 1 2/3, right? Because I can use 3 hours to plant 1 acre, and I can use 2 hours to plant 2/3 of an acre. And if I take 1.67 times $96, I will get $160.32. So 5 hours of labor returns $160 of profit in terms of soybeans, but only $120 of corn. So our limiting resources are going to be a big determinant of what maximizes overall profit. So I'm going to go through this again just briefly. If we look at table 11-8, it might seem as though there would be no reason to plant soybeans. I've got enough money to plant 120 acres of corn. I obviously have enough land to plant 120 acres of corn, but I don't have enough labor. If I only plant corn because I think that's going to maximize profit, because clearly its profit per acre is the highest, I'm going to run out of labor and my overall profit will not be maximized. Remember, the goal of a firm is not to maximize profit per hour of labor, to maximize profit per acre planted. It's to maximize profit overall. We're thinking about this like economists. The 5 hours of labor that we use for corn, we're identifying that as a cost. It still is taken out of our revenue, but it doesn't change the fact that we only have 500 hours of labor. So if we're sweeping aside any agronomic issue between planting corn and beans in a rotation, and we're saying this is the only decision that we have is based on profit, you might think plant only corn. But when you realize the trade-off from corn is not 1-to-1 in terms of acres, it's 1 to 1 2/3 in terms of acres because of my labor requirement. Okay, if you watch this first, maybe all you hear is wah, 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 wah. But read, watch again. It's only 12 minutes long. So have a great weekend, and I will see you on Monday at the regular time.